So, Google just dropped Vista, an AI that basically teaches itself how to make better videos every time it runs. It doesn't retrain, it doesn't fine-tune, it just rewrites its own prompts, learns from its mistakes, and keeps improving until the results look shockingly good. And it actually beat V3, Google's own top video model, with a 60% win rate. This might be the start of AI video that literally evolves in real time. So, let's talk about it. Alright, here's how it actually works. Vista takes your video idea and breaks it down into a structured plan, scene by scene. Each scene gets 9 properties: duration, scene type, characters, actions, dialogues, visual environment, camera work, sounds, and mood. So, instead of just throwing a prompt at a video generator and hoping for the best, Vista maps out exactly what should happen and when. Then it generates multiple video candidates and runs them through what they're calling a tournament-based evaluation system. Basically, videos go head-to-head in pairwise comparisons, and the best ones advance. But here's where it gets clever. Before comparing, the system generates what they call probing critiques for each video. So the AI isn't just blindly judging. It's actually analyzing each video first, then using those insights to make fairer comparisons. Once the best video is selected, the model brings in a trio of specialized judges to critique the winner across 3 dimensions: visual, audio, and context. And within each dimension, there's a normal judge that scores the video, an adversarial judge that actively looks for problems and tries to poke holes in the quality, and then a meta-judge that synthesizes both perspectives. This jury-style setup is inspired by actual legal decision processes, and it's designed to catch issues that a single judge would miss. Each dimension has its own detailed metrics. For visual, they're looking at things like visual fidelity, motion dynamics, temporal consistency, camera focus, and visual safety. For audio, it's audio quality, audio-video alignment, and audio safety. And for context, they're checking situational appropriateness, semantic coherence, text-video alignment, physical common sense, engagement, and video format, like whether the beginning and ending are smooth or if transitions feel natural. After all that critique, Vista uses something called a deep thinking prompting agent to actually rewrite the prompt. And it's not just a quick tweak. The agent essentially goes through 6 reasoning steps: identifying what's broken based on low scores, clarifying what the expected outcome should be, checking if the prompt has enough detail, figuring out if failures are due to model limits or bad prompting, detecting conflicts or vague language, and then proposing targeted modifications. Only after that introspection does it sample new, improved prompts. Then the whole cycle repeats. New videos get generated, the best one is selected, critiques happen again, and the prompt gets refined again. By default, Vista runs 5 iterations, 1 initialization round, and 4 self-improvement loops. In each iteration, it samples 5 prompts with 3 variants each and generates 2 videos per prompt. So, you're looking at 30 videos per iteration. That's a lot of test time compute, but the results justify it. The benchmarks say a lot. The team tested Vista on 2 datasets. One with single-scene prompts from MovieGen Video, and another multi-scene internal set. The first had 100 prompts. The second had 161. When compared to direct prompting, which just uses the raw user prompt with no optimization, Vista performed far better. By the 5th iteration, it was winning 45. 9% of single-scene tests and 46. 3% of multi-scene ones. A gap of around 32 to 35% between wins and losses. Alright. Now, you know how meetings usually go. Endless talking, half the people taking notes, and by the end, no one remembers who's supposed to do what. That's exactly what ProActor, who are sponsoring today's video, was built to fix. ProActor is your AI teammate that joins every meeting, class, or call. And it doesn't just listen. It transcribes everything in real time, highlights key points, and automatically creates summaries and action items so you never miss a detail again. But here's where it really stands out. ProActor thinks ahead. When someone asks a question mid-meeting, it instantly researches and delivers the answer on the spot. If a new task comes up, it identifies it, tracks it, and keeps everyone aligned without you having to lift a finger. It works across meetings, lectures, sales calls, and interviews, remembering everything from past sessions, so it feels like working with a teammate who actually knows your history. And yes, all data is processed securely on AWS servers, fully compliant with GDPR and CCPA standards. Whether you're in business, education, or sales, this tool makes meetings smarter, faster, and more productive. Try it free at ProActor AI, links in the description. Alright, now back to Google's Vista. They also ran it against other optimization methods like Visual Self-Refine, Google Cloud's Rewrite tool, and VPO. Those approaches showed mixed or inconsistent improvements. Sometimes they even got worse with more iterations. Visual self-refine, for example, started strong but quickly plateaued. VPO and rewrite bounced around without a clear trend. Vista, on the other hand, kept improving steadily with every iteration, which shows it's actually learning rather than just getting lucky with better samples. To back this up, they brought in 5 annotators experienced in prompt optimization to compare Vista's results to the best competing models after 5 iterations. Vista won 4% of those comparisons. Expert evaluators were also asked to rate full optimization runs on a 1.5 scale. Vista averaged 3.78, while the next best baseline scored only 3.33. Looking at specific metrics, Vista boosted visual quality scores from 3.36 to 3.77 and audio quality from 3.21 to 3.47. The annotator scores varied a bit, which makes sense. Video quality can be subjective, and people focus on different things like realism, smoothness, or sound. Still, across the board, they consistently preferred Vista's outputs. Now let's talk about the technical setup. The model uses Gemini 2.5 Flash as the multimodal large language model and V3 as the video generator. Both are state-of-the-art. They also tested it with a weaker model V2, and Vista still improved performance, pushing win rates to 23.8% in single scene and 33.3% in multi-scene. That's not as strong as with V3, which makes sense. V2 just can't leverage all the detail Vista optimizes for. But the fact that it works at all with a less capable model is a good sign for generalization. One thing they measured was cost. Vista uses about 7 million tokens per iteration on average. Most of that comes from the tournament selection phase because each video input is over 2,000 tokens. They also generate around 28 videos per iteration. That's expensive. But the performance scales with compute, which is what you want. When they pushed Vista to 20 iterations in single-scene tests, it kept improving steadily. While the best baseline, visual self-refine plus, plateaued and got noisy. In multi-scene tests, they ran a lightweight version of Vista for 20 iterations and saw the same trend. Consistent upward trajectory while the baseline stalled. They also ran ablation tests to see which parts of Vista actually make a difference. And the answer was all of them. Without video planning, quality dropped. Without tournaments, results got unstable. Using only one judge broke multi-scene runs, and removing the deep thinking agent stopped progress. Every piece of Vista's loop pulls its weight. One of the more interesting behaviors they documented is how Vista handles hallucinations. V3, like most video models, sometimes generates stuff that wasn't requested. Random text overlays, music when none was asked for, objects appearing or disappearing, characters moving in physically impossible ways. Vista reduces this by enforcing strict constraints during planning and applying penalties during selection if a video violates those constraints. For example, unless the user explicitly asks for captions, the model penalizes videos that have them. Same for music or voiceovers. It also penalizes videos where objects or characters move at unnatural speeds or in nonsensical directions. That alone filters out a lot of the weirdness. They also found that this model improves instruction following. In one test, they asked for a factory scene with a blade battery on a conveyor, a yellow industrial robot, and a screen showing a yield percentage in simplified Chinese. Direct prompting failed to include the robot or got the text wrong. Vista nailed it. In another test, they wanted a scene with gremlins on a wooden roller coaster moving forward while the camera tracked backward. Direct prompting generated gremlins moving backward super fast, which looked ridiculous and broke physics. Vista fixed it. Gremlins forward, camera backward, everything's smooth. These aren't just minor tweaks. They're the difference between a usable video and something you delete immediately. Now, this whole thing fits into a bigger trend in AI research right now. Test time optimization. Instead of training bigger models or fine-tuning on specific tasks, you're using compute at inference time to search for better outputs. OpenAI is doing this with reasoning models, and now Vista is doing it for video generation. The paper notes that this is the first black box test time prompt optimization framework for video. Previous methods either required white box access to the model or focused on narrow aspects like object presence or harmlessness. This model is the first to jointly optimize visual, audio, and context dimensions in one loop, but there are still limits. The system depends on multimodal LLMs as judges, which can introduce bias. Human evaluations helped balance that, but they're costly and don't scale well. The quality metrics themselves also assume a certain creative style that might not fit every context. And since Vista's performance depends on how good the underlying models are, it can only improve as they do. It's powerful but not magic. Still, the results speak for themselves. Vista beat V3 in 60% of tests, won 66.4% of human evaluations, and showed steady improvement with each iteration. It followed instructions better, reduced hallucinations, handled multi-scene videos more smoothly, and kept audio and visuals in sync, all at test time without retraining. That's a huge leap for automated video creation, opening doors for media, marketing, education, and entertainment. With self-optimizing video generation, you can slash production costs, speed up workflows, and scale content like never before. So the question is, are we looking at the future of AI video creation, or just the first glimpse of something much bigger? Let me know what you think in the comments. Make sure to subscribe AI Unlocked.